plants who can survive the drought, they have more polyphenols in them. And those polyphenols or other pigments, so which can survive them, they will make the color of the honey darker. So that's why the plants are darker in summer, and that's why, yes. Sure. So the dark color of the fall honey comes from the plants that are foraged inside during the summertime, because those plants are more resistant to drought, and then that's why the nectar that's collected from them is darker. So the tannins and polyphenols in the summer plants make the color of the honey darker. Yeah, it is the nectar that's being collected. Nectar and honeydew that's being collected makes the color darker. Okay, yes, we can click on got it.
Get the mouse over there.
No, don't leave the meeting.
You can't click on that screen. You can click on that screen.
No.
I think we cannot click on next either.
There you go.
There you go. Oh, nope.
Soon.
We'll get there. No, he's working on it. Anyway, we can talk more about other stuff. Okay. So what my job is, what I do at the university is we are finding out what are the components inside the honey so that we can identify their medical potential. So what makes honey medical grade is the contents inside them. So the sugar itself is already a medical property, that's true. But on the other hand, there are some other products inside the honey that makes it more medical, like the polyphenols, the tannins, the flavonoids. So these are the things that already, most of the medicine in today's world are how they are made. Are they synthetic or are they extracts? About 60% are plant extracts. So think about aspirin. It's salicylic acid, which is extracted from the sativum tree. I forgot the tree's name. But most of the drugs or medication that we are using now are extracts from the plants. So like these honeybees are doing the same thing. They're extracting the chemicals from the plants like the chemists or like the pharmacologicals or pharmaceuticals. So that's what the honeybees are doing for us. So they collect those chemicals from the plants and they put them into the honey. So when we consume them, we are getting those medical properties from those honeybees. So they're good friends. Okay, now, is honey medicinal? Yes, that's why we are here. But how do you use honey for medicine? You can write onto the tablet or you can just raise your hand. What kind of medical purposes do you use honey if you use at home? Yes. Sore throat, great. How do you use it? Just like mix it with lemon, okay. Cuts and abrasions and incisions, yes, for wound healing. Anything else? Antifungal, okay. Antimicrobial, yes. Okay, tolerance to allergies. Yes. For severe burns, yes, burn and wound healing. It is the most common that the honey is being used. Yes. What was it, sir? Okay, what's yes, flu and cold, especially mostly for the cough, for the children. So there are some studies that are showing that, like when the children who has cough at night, and I also applied my kids several times. I have 2 kids, 2 and 6, and they, as you know, they go to the school and they get sick. So we give them honey at night before they sleep, and their cough is more suppressed. And there are clinical trials that has compared the cough syrups or cough drops with honey only, and honey is as efficient or even sometimes more efficient than the cough medicine. And it was published on the what's called one of the scientific journals. I forgot the name, but it was a clinical trial that has shown that. Okay, so next, please. So honey is medicine. Not only for today, but honey has been a medicine for thousands of years by almost every civilization on earth, like Hittites, Sumerians, Babylonians, Chinese, Indian, Greeks, Romans, Persians, Turks, Arabs. They all used honey as a medicine. And then honey was also being much revealed in the scriptures, like in the Bible, in the Psalms, in the Torah, in the Quran. So honey is being like revealed as a medical product. And for example, this one is in 1600 BC when they found the Egyptian papyrus. So this was explaining how to use honey for medicine in the Egyptian, the healers. And then this one is about the honeybee's script. So this is an Arabic script. Probably, if you know, that's the calligraphy. So it has been Arabic calligraphy that is writing those two verses in the Quran, which says, God has created a fluid, a different fluid with varying colors, and which is the healing for mankind. So it clearly says in the Quran that honey is a healing for mankind, and then it has different colors. So for some scholars, they say like different colors of honey can be a healing or can be a medical benefit for different diseases. So next, please. And honey is being used again and still being used as a wound, as different medical properties. So I will cover some of these, like I will go with the antimicrobial, antioxidant, and a little bit anti-inflammatory. But let's talk about honey as an anti-diabetic. So honey is 76% sugar. But honey is being shown to work in the animal models and human clinical trials to be used as an anti-diabetic agent, especially for the type 2 diabetes. Again, this is not a medical presentation, but there are evidence that shows that honey is anti-diabetic. If it is sugar, 76% sugar, how come honey can be anti-diabetic? It has very little amount of sucrose. Okay, that's very good because again, most of the sugars that we have in our coffee, tea, or other, it is sucrose. What else? But in this case, you can simply eat glucose and fructose syrup as well, which is we consume a lot of high fructose corn syrup in all these different sweetened liquids or the beverages. Aha, we have some good studying students here. Yes. So, are you guys familiar with the glycemic index? So, can somebody help me to explain what it is? Do we have glycemic index? Glycemic index. Yeah, sorry, I'm teaching biology for so many years. I'm still not pronouncing everything well. Yes, we have someone here. She is very comfortable here. I don't want to.
That's right.
Okay.
Glycemic index is the rate at which food is digested and the sugars are given into the bloodstream.
Great, give her a big applause. Yes. This is what glycemic index is. So different foods have different glycemic index. So there are high glycemic index and low glycemic index sugars or foods. So when you eat candy or when you eat granulated sugar or chocolate, when you feel low blood sugar, hypoglycemic, you don't have any energy, you eat it and then suddenly you got like high amount of energy, but after 30 minutes, you want to eat again, right? So this is for high glycemic index or high glycemic index foods. So they go into the blood very quickly, but they also clear out really quickly. So in this case, the insulin is released when there's high blood glucose level. Insulin is released very quickly, and then all the cells take out the glucose, and again, we got the low glucose in the blood. So this is what happens when we consume high glycemic index food. But on the other hand, there are low glycemic index food, which means that the glucose inside that food, you remember glucose is our major, if you remember from the biology, mitochondria, the powerhouse of the cell. So glucose is used by the oxygen that has been converted into energy, right? So the ATP. So glucose is the main source of energy for our cells. So if it is released slowly, then our cells will get it slowly, and it will not spike our insulin levels. So that's why low glycemic index or low glycemic food can be consumed by the diabetic patients as long as it is, it is under dietitian control. So honey is a low glycemic index food. So which means that the sugars inside the honey, they go into our blood system slowly. And it doesn't spike our insulin, and it doesn't affect our blood glucose level very quickly. So, and it has been shown the athletes, when they use honey before and after the workout, they have shown that their endurance level has increased Because when you consume honey or honey drink, actually, most of the time they do use honey drink. So when they add honey into their drinks or drink honey by just with water, so the athletes, they have more energy throughout their workouts. So you can try it for yourself. I mean, you will feel that you have more energy or long-term energy, not just finish very quickly, but longer term when the honey is like consumed for the energy purposes. So honey will not make you feel full very quickly, slow. Okay, so that's how antidiabetic. So honey has been shown to be anti-tumor. I will have some images for this. And gastroprotective. So what is gastroprotective? Gastric. Our guts, right? Like stomach and bowels and intestines, all of them. So gastroprotective. So how do you think honey can be used for gastroprotective agent? So how can you use honey for your guts, your stomach, your bowels? It can be like a coating. Okay, very good. Oh. Yes, it's a honey is antibacterial. So again, do you remember which bacteria causes the ulcer? Or Helicobacter pylori, like helicopter kind of thing, Helicobacter pylori. So honey has been shown to kill that one. So the patients, the ulcer patients who consume honey, the first thing in the morning with an empty stomach, it has been shown that honey treats the ulcer on those patients. And my mom was diagnosed with ulcer last year, and I told her to keep consuming honey every single morning. She was eating 2 tablespoons every morning, but anyway. So, and then her ulcer is completely cleaned out. Again, these are personal experiences, not medical advice, but you can try if you are honey beekeepers. Okay, so that's one of them. What about the bowels? Bowels, bowels, yes. Sorry, I wasn't born and raised in here. Yeah, bowels, yes. Guts. Guts is easier to pronounce. Okay, yes, sir. It neutralizes stomach acid. Maybe yes. I'm not very sure, but it will help. But what else? It's a probiotic. Yes, honey has some probiotic properties in it. So it is like what happens is that we have an organ which has been described as an organ recently, which is called our microbiome. So what is microbiome? Which is like what is inside our body? This is the bacteria that we live. So microbiome is the microbes or microbiological organisms that live with us. And the number of microbe cells in our body is 10 times more than our human cells, which means that we are 90% bacteria, 10% human in terms of the cells. Yes, so they are part of us. So we live in peace with them. If we don't have bacteria, we cannot digest the food. Remember the babies, when they're born, can they eat baklava? No, because their digestive system is not ready for it, right? That's why they only consume like milk, which is only digested in the stomach. So that's why we need bacteria for digestion and for the purposes. And when microbes, like when the good microbes win, we have a healthy gut. When the bad microbes win, we have a sick gut or overreactive gut, right? And these overreactive can be either constipation, diarrhea, colitis, Crohn's, or other diseases. Name it. Or leaking, whatever. Leaking guts. What about if you hold the water? Non-leaky? Okay. So leaky guts or the other way. Okay. So this is controlled, and this is mostly related with the gut microbiome. So if the good bacteria is winning, we have healthy. If the bad microbes are winning, we have gastrointestinal diseases. Okay. So in this case, honey is helping for the good bacteria to win. So if I tell you, you can use honey for both diarrhea and constipation, would you believe that? How come? Come on, they're opposite of each other. One is leaky, one is not leaky. How can you control it? Don't accept everything that I say. Come on, challenge me. So, honey creates neutrality. Okay. Yes.
Extremes of the positive environment, both of which are positively affected.
Okay, they are both positively affected by taking honey. Okay, That is a good approach. And I mean, that's close, yes. So in this case, we have something, another player in the game. We have water. So when you dilute the honey in water, remember honey has enzymes in it. So these enzymes are mostly coming from the bees. And one of the enzymes inside the honey is glucose oxidase. So from the name, you can see it oxides the glucose. So we have lots of glucose in honey. So when honey is diluted in water, this enzyme will be activated. So glucose and water will be converted into gluconic acid and hydrogen peroxide. So what is hydrogen peroxide? What do we use it for? It kills bacteria, right? We use it for wound cleaning, but we use this like small amount because if you use a high percentage, it will kill our own cells as well. So that's why we need to dilute the hydrogen peroxide. So what happens when the honey is diluted in water, hydrogen peroxide is being produced. But here's the key. When the honey is diluted in warm water, more hydrogen peroxide is produced. When the honey is diluted in cold water, less peroxide is produced. So by diluting honey in warm or cold water, you can kind of adjust the amount of peroxide. And by this way, you can help the gut microbiome to balance it out. So the key is this. When you have constipation, you need to use warm honey drink. When you have diarrhea, we need to use cold honey drink. Don't use the opposite, okay? It will be more leaky. Yeah, I mean, not straight honey, but yes. So again, there are studies showing that. So the warm honey drink helps for the constipation. Cold honey drink helps for the diarrhea. And what I personally do is how I use myself, because I have IBS, irritable bowel syndrome. I have both of them from time to time. So when I have diarrhea, I put cold Gatorade or something, or sometimes just the water itself, like from the refrigerator, and I put honey into it, dissolve it, and drink it. Sometimes I drink more than 1 cup if it is so leaky. So sometimes it's less. But when it is constipation, you need to put, we never put honey. Okay, this is a revolutionary thing, I think, for some of you. But how many of you put honey directly into hot coffee, hot tea, or hot water? Okay, don't do it. Don't. Okay, tell me why you should not do it. Can somebody help me? Yes. Heat kills the enzymes, the proteins, the amino acids inside the honey, because proteins are denatured in the hot temperature. So when you put the honey into the, when you pour hot water into the meat, what happens? Like it changes the color, right? Meat is not red anymore, it becomes brownish. Like when you direct the boiling water onto the meat, it's like this. Honey has enzymes, proteins in it. So when you put the honey into the hot drink, or when you put hot drink into the honey, it will just kill the enzyme. It is still a sweetener. It is still a sugar. You will get sweetness, but you will not get medical properties. So how would you make the warm honey then? Warm honey drink. Yes, do you have a question?
Does it become toxic or does it just become inert and it's just?
Yeah, it is just a sweetener. It will lose most of the proteins. The minerals will stay same. Minerals don't go with the heating, but most of the other organic compounds in it will die. Except the sugars are okay. Sugars are also caramelized eventually. That's why we have caramel and all those things when you heat the sugar. Okay, how would you make the warm honey drink then, if you cannot go from the hot? Okay, yeah, you can just make your warm water, but what I personally do is, I just dilute the honey in room temperature water, and I add hot water on top of it, so it heats up. It doesn't cool down, it heats up. So when it heats up, you still have warm honey drink, okay? So you can start from the room temperature and add hot water onto it. Adding hot water will not kill the honey at that moment, because it is still cold, like still room temperature. Yes. Yes, there is a 55 degrees is the cutoff for the enzymes, for the proteins to denature. 55 degrees Fahrenheit, sorry, Celsius, not Fahrenheit. Otherwise, it would be cold. Yeah, 55 degrees is the cutoff, like in the biology classes, that's how we learn. And then it's about 130 Fahrenheit, I think. But there's an easy way to measure it. So use your pinky finger, dip it into the water. If it burns, it's too hot. Okay? Or if you try to drink it and if it burns your lips, it's too hot. So it is drinkable temperature. As long as your coffee or tea or water is a drinkable temperature, it is okay for the honey to be dissolved in it. Okay? Easy measurement. So just like if it burns you, it burns honey as well. Okay. So that's the gastroparetic one. Next, please. Yeah, oh, sorry.
Like, if you go to the store, a lot of honey is blended with water and all kinds of other stuff. You're talking about.
Like infused ones,
What's that?
infused honeys.
So you go to a grocery store, you're gonna make sure it's raw or pure honey. All of this conversations on raw and pure honey. right?
All of these conversations about like honey that the beekeepers are extra harvesting from their own hives. I'm not talking about the grocery store honeys because according to the several studies, like what is done in France about like 2 months ago, about 60 to 70% of honeys at the grocery stores are not honey or they are not pure honey. They are blended with other glucose syrup, fructose syrup, they're adulterated. Yes. You need to add some cold water into it or something. So make it cooler and then you can, or warmer, and then you can add honey into it. Okay, any other questions that I will move? Okay, so now let's talk about antibacterial. So what makes honey antibacterial? What inside the honey can kill the bacteria? Yes. Low water content, great, or high osmolarity, low water content, high sugar content, same thing. Yes. When you then have, like, think about yourself in the Texas heat, like 110 Fahrenheit outside, you are dealing with the bees. What happens to you? You lose water, right? You got dehydrated. And when you're dehydrated, what happens? If you don't drink water, you pass over or just like you go to the emergency. I mean, hope not. So you have to get hydrated. So hydration is important. Same thing for bacteria. The bacteria has to be hydrated. So if you put honey on top of the bacteria, they got dehydrated because they don't have any water. So this thing, like high sugar content or low water content, doesn't allow the bacteria to live inside the honey or when the honey is present. That's number one. Yes.
We had very low last year. We had like 30.
In the honey? It can happen, but it is the average is about 15 to 18%, depending on the region. Yeah, it's too low, but I don't know why. But it will, if it is too low, probably because of the drought. And for example, in tropical areas, when it is very moist, it is 21%, 20% acceptable. Okay, let me ask the other way. What if your percentage in your honey is 23%? What will happen? It will ferment and you will get mead out of it. So the alcohol. Yes, sir. It's antibacterial. It's a desiccant, but there are other properties. That's just one of them. So in this case, if you add high sugar solution, like if you, for example, if you dilute the table sugar, if you make 80% table sugar, like when you are giving to the honeybees, some people give. So you still, and there are doctors who are using high sugar content for the wound healing because it still kills the bacteria there, but it's not enough by itself. Yes. The viscosity, yes, it's most related with the moisture though. We mentioned about one chemical, remember? The anaerobic fuel, kind of, yet it may absorb some of the oxygen, that's true. But remember the chemical that we talked about recently. When you dilute the honey in water, what is released? Hydrogen peroxide. And hydrogen peroxide is antiseptic agent. It's an antibacterial agent. It kills the bacteria, but you need to have a small amount. So can you go next, please? Next. So high sugar concentration is one of them. The other one is hydrogen peroxide. So when the honey is diluted in water, so much hydrogen peroxide produced, but this hydrogen peroxide is enough to kill the bacteria, but not enough to kill the human cells. And the reason for that one is human cells are at least 10 times larger than the bacterial cell. So it is enough to kill the small end cells, but not enough to kill the large cells. So that's why the peroxide, and when the honey is diluted in water, it doesn't convert immediately. It's an enzymatic process. It goes by time. So the more honey is there, the more longer time, the more peroxide is produced. So like again, when we do wound cleaning, so we add the peroxide and clean it and move it, right? No more peroxide is left. But in honey, the peroxide is 0.3%. So when you buy peroxide from the hydrogen peroxide from the Walgreens or other place, it is 3%. The honey, 0.3% or even less. And it is continuous. That's how it kills the bacteria. So peroxide activity is another property. And acidity. Remember, not all honeys are created equal. So different honeys have different acidity. And how do you identify acidity? Like when you eat honey, how do you think it is acidic? Balance. You don't. If you don't have pH meter, like when you eat it, how do you taste the acidity? Tartness, or it is tingling your throat. It's kind of a little bit burning. So this is most of the time it is the acidity. Okay. So honey is acidic as low as 2.5 all the way to 5.2 or 5.3. So this acidity does not allow the bacteria to flourish, because for most of the pathogenic bacteria like E. coli, Salmonella, Staph aureus, they love pH 5 or 6. But when you put them pH 3, they said, no, I cannot grow here. So they don't like the acidic environment, and that's why our stomach kills most of the bacteria, right? And then the last one is organic antibacterial compounds. So this is the major thing. This almost all these activities like high sugar concentration, acidity, and hydrogen peroxide. So these are common for almost all the honeys. But this one, organic antibacterial compounds, which are coming from polyphenols, tannins, flavonoids. So these are the ones that make honey medical grade. So this is the one that differs from honey to another honey. So the organic antibacterial compounds is the main components, are the main components of honey that differentiates medical grade honey from normal food grade honey. Okay, and we'll talk about this a little later about our study. Next, please. Okay, so how does the honey kill the bacteria? So these are different mechanisms. If you are familiar with the biology or microbiology, so honey will inhibit the cell wall synthesis, so the bacteria cannot have their cell wall, so they'll be leaky. And it causes oxidative stress because of the peroxide, and it inhibits the enzyme activity. It initiates incorporate with the DNA, and it also goes into the phospholipids, like it penetrates the cell membrane. And it also prevents the cell signaling. And one of the most important things is the biofilm. So honey prevents the biofilm formation. So what is biofilm? It's a movie. It's a biological movie, biofilm.
That is I keep thinking of these escape bubbles, but that is how the bad guys hide.
Yeah, this is the gang of the microbes.
And then they pop back out.
And then they go for another one.
So once you break down the biofilm, then you get to the bad guys.
So in the wound healing, one of the major problems is the biofilm formation, because the slimeness on the wounds, when you have a wound, open wound, when you touch it, it is slimy, which means there's an infection in it, and it's a biofilm. Or if you want to touch a biofilm, touch your teeth. It's the biofilm after we eat, and if you don't brush it, so one of the reasons that we brush our teeth is to break down the biofilm formation, because we have lots of bacteria living in our mouth, and they are making biofilms there. So biofilm is different bacterial gangs or pathogens. They get together and they release some polysaccharide, like some kind of sugar. So they coat themselves, and the antibiotics cannot penetrate into the biofilms. And that's why antibiotic ointments will not be effective on the biofilms, because they're both bacteria and fungi. They live together and they have a protective, it's called the David's dome, or like, when you have the anti-missile protection thing. Yeah, something like those bacteria have that protection. But honey has been shown to degrade that biofilm. Yes.
Like every 5 years, there is a massive, I want to say, a good invasion of plantain. So the plantain plant is also a biofilm buster. So now you combine that with the bees foraging for this.
That's cool.
Is
Okay.
great.
Yeah, and honey is not the only biofilm buster, by the way. There are propolis does the same thing. There are other honeybee products does, and there are also plants doing that. Yes, thank you. Okay, next, please. So these are some of the bacteria that has been extracted from the patient's wounds. So these are about 102 patients were treated by just using honey, and they used different antibiotics, and those conventional antibiotics didn't kill. So these are 23 different bacteria that has been isolated or cultured from the human wounds. And the interesting thing is that, so these are all pathogens. These are the ones that causes the wound not to get healed. But look at number 1 and 7. Do you see something different with them, those arrows? What kind of bacteria are there? They are resistant bacteria. What does resistant bacteria mean? I mean, what's wrong with them? Are they resisting something? They are resisting the antibiotics, which means that the conventional antibiotics cannot kill those bacteria. And then, so before COVID was hit by 2020, World Health Organization declared another pandemic. Most of us did not hear about this. But because it is a slowly ongoing pandemic, which is called antimicrobial resistance, AMR. So AMR is an ongoing pandemic that is threatening the whole world. By 2050, AMR is expected to kill more than 10 million people per year. It is causing hospital infections. And those hospital infections are ending up with death, with sepsis. And antimicrobial resistance is an ongoing and increasing crisis because these bacteria are learning how to resist antibiotics, and then our conventional antibiotics are not killing them. In 2017, in Nevada, there was a patient, a senior lady. She had an infection on her thigh, and then she got Klebsiella pneumonia, but resistant one. And then that bacteria could not be killed by trying 27 different antibiotics available on the medical market. So 27 different antibiotics could not kill the bacteria, and we lost the lady because of sepsis, so multiple organ failure. This was an alarming point for the US. It was like in other countries it was seen, but it was the first case in the US in 2017 when we had AMR has killed first patient and keeps killing. So we need to have more antibiotics. But the problem is the new antibiotics are not affecting all these resistant bacteria. And antibiotics will, these AMR, the resistant bacteria will continue to kill more people as the years pass. So it looks like there is no hope. But when there is no hope, there is honey and bees. Yes. Yes. So as you see here, and so many other studies, honey has been shown to kill majority of the resistant bacteria. And the bacteria could not gain resistance to honey. Remember the previous slide? Honey is attacking the bacteria from all different ways, not only for the cell wall, not only for the cell membrane, not only for the DNA, or not only for the enzymatic reactions. It is attacking from all different directions altogether. So this is one of the major reasons that honey can kill resistant bacteria. Honey is killing vancomycin resistant bacteria or medicine resistant bacteria. Not all the honeys do this, by the way. Some like high antibacterial honeys can do this, like when they have high potential. Next, please. Honey is antioxidant, yes. Cancer is not a bacteria, but I will show some image that honey can help with the treatment of the cancer. I cannot say honey heals the cancer directly, but it helps for the healing. And I'll show some images. So honey is antioxidant agent. So what does the oxidants do to our body? Why do we need to get antioxidants? Like, why do people keep telling you we need to consume antioxidant food, like the berries or pomegranates or so? Why do we need to have antioxidant foods? How does it help us? Yes. Very good. So our cells will undergo cancer if we don't have antioxidants. Because antioxidants are the oxidants or reactive oxygen species, they are called ROS. So these are the byproducts of our cell metabolism. So when our cells produce oxygen, when our cells produce energy from oxygen, so we will have some chemicals which may cause cancer or mutations in our cells, and antioxidants are preventing this. Or if it's not cancer, then the cell is getting aged, so like senescent. So honey has become an anti-aging product as well because it has antioxidant products in it. So what they do is, this image shows here, so normally those free radicals or reactive oxygen species, they will be stealing electrons from the healthy molecules or healthy cells. So what they do is, when they steal an electron, they will become unstable as well, and this will cause mutation. But antioxidant, they will just give and like they will say, okay, take this electron, don't steal it, I have one for you. So that's what the antioxidants do. So honey is giving antioxidant, the antioxidant inside the honey is helping the or scavenging these ROS, reactive oxygen species. So by this way, it is preventing the senescence or aging of the cell, and it's also preventing the cancer. Next, please. And honey has been shown to be helpful for different cancer types in the lab, in vitro studies, not in vivo, most of them, like breast cancer, colorectal cancer, renal, prostate, endometrial, cervical, and oral. So we couldn't find a cure for cancer yet, although like thousands of or tens of thousands of doctors are working, researchers are working. Why don't we have a cure for cancer yet? What's wrong with it? No, it's not the money only. Is it one type of, like cancer is a one disease, a single disease?
Turns into different things. You know.
Okay, it goes metastasize, it becomes a different one. But like, do we have only one type of cancer? Yes, sir. Very true, yes. So there are like more than 30 different cancer types has been identified. And then we have about 204 different cell types in our body, and all of them are prone to be cancerous. I mean, except the red blood cells because they don't have a nucleus. But most of them, they have, like, they can be carcinogenic. And even for one cancer, let's say breast cancer, there is not only one type of breast cancer. Like there is mutagen positive, another mutagen negative, hex, I forgot the names, but so there are like different types even then. So like cancer is not, there's not a one cancer. That's why we don't have a one cure for one cancer. So that's for each cancer is specific. But honey has been shown to help for the healing as an alleviating agent or as an adjuvant for the cancer therapy. It has been shown in the animal models. Next, please. So in this patient, which is the one of the breast is removed as a mastectomy. So it's a breast cancer. You can see the other breast here. So the patient is a recurring cancer cells on the removed breast. And then they applied the honey sheets on the recurring cancer tissue. And then in day 2, as you can see, all these squamous cells or recurrent cells are removed in 1-day treatment of the honey. So honey has been suppressed to regrowth of the bacteria or the cancer cells just by using made honey HCS sheet dressing on 1 day. And this is only one study, but there are so many other studies. Honey has been shown. Another one is question. So what is one of the most common side effects of chemotherapy? Like hair loss is one of them. Weight loss is another one. Stomach, nausea. What about the mouth? Dry mouth or mucositis? So which is the inflammation of the buccal mucosa inside our mouth? So those mucosal cells are epithelial cells. And when there's inflammation, so it will cause like a very serious issue inside the mouth. That's why the chemotherapy patients are having buccal diseases or buccal, when they're exposed. So there's a study showing that, and also it's a clinical trial. If you go to clinicaltrials.gov and write honey and cancer, you will see these results from there. So it was, I think it's a completed study, but maybe they will have other ones. But what they did was, they gave honey to the patients who are going chemotherapy, and they hold the honey in their mouth for a while. And that honey, because the digestion of the carbohydrates start inside the mouth with the enzymes, so that honey has prevented the mucositis in those chemotherapy patients. So from here, we can say that like you can use honey, the chemotherapy patients, they can use honey as they hold them in their mouth to prevent the mucositis, the inflammation inside the mouth. So honey is a preventive agent and also an alleviating agent for the side effects of the chemotherapy. But again, there are other studies still ongoing that use of honey for different cancer types. Next. Okay, good question. Is there any botulism inside the honey? Or actually, so what botulism, what causes botulism? Botulism, food poisoning. And also Botox that people do on their faces. It's the same chemical.
What, you make fun of
Me, not you. I mean, not me either. Some people do Botox because it's the botulinum toxin. So the botulinum toxin comes from Clostridium botulinum bacteria. And then those normally bacteria cannot live inside the honey, but there are spores which can resist for it's true. So there are spores of the honey, inside the bacteria that can survive for years or even hundreds of years. So today, some of the scientists, they discovered spores from like hundreds of years ago, and then they have the bacteria from there. So these spores can survive inside the honey. So when we consume the honey, those spores can invigorate, revive, and they become alive again, and then they can cause disease. So, but most of the time, it causes some kind of like loosening or leaking in the in the bubbles. But most of the time, these Clostridium spores are not part of the bee or are not part of the honey normally. They are mostly coming as airborne, which means that, like, for example, when we are here, there are fungus, other spores in this air. Although we are cleaning it, there's still some bacteria. That's why we were using masks, right? Because COVID was airborne. So, and those airborne spores can land into the honey when the beekeepers are harvesting it. So that's why if the beekeeper is not hygienic enough or there's not enough ventilation, those spores can land in the honey and they can stay there until we consume it. And once we consume it, especially if the infants consume it, those botulism spores can come back to life and it can cause food poisoning. But again, for us, it is very slight. But for babies, because their gut microbiome is not developed yet, it can cause a little bit more diarrhea. But I will tell another thing. So this is the reason that they say, do not feed the infants under 1 year old with honey. But I fed my own son when he was only 2 months old with honey. Why did I do that? Because because I trust my honey. So this is the thing. So I always tell people, when people ask me which honey should I use, I always take comb honey, because comb honey is sterile. So the beekeepers work very sterile. So they don't allow anything to go into the honey when they are doing this. Okay, because inside the honey as well, there are lots of antibacterial measurements they are taking. Like they put propolis for their health. And as well as, so no bacteria can be put into there are some lactobacillus inside the honey that will survive. But so it is sterile, so it doesn't cause, there is no pathogenic bacteria inside the honey, in the comb. So when the comb is sealed, the honey inside the comb is like sterile. So it is useful. It's like we can consider it. But when the people are harvesting it or packing it or storing it, so in those cases, so there is more spores can be introduced. Okay, when the humans touch the honey, then pathogens can be introduced as well. So that's why I always try to consume comb honey, and I recommend people to use comb honey for the medical purpose most of the time. So it's about I talk too much about it, but I'm sorry, the time is going up as well. So honey is immunomodulatory agent. So what happens is that we always need to feed our immune system, right? Our immune system should be ready for diseases. Otherwise, if our immune system is not ready, we get sick very easily. Like, for example, the patients who are using chemotherapy medications, they are immunocompromised. Or there are people who has genetically immunocompromised, which means that their immune cells are not active. Did you watch the Bubble Boy? So that boy lives in a bubble because his immune system immune cells are not ready. So, and we need immune boosters for our own cells. Most of the time we say we consume vitamin C or other things to boost our immune system. But honey has been shown to be an immune booster as well. And can you click on next, please? So honey has been contributing to boost our immune system with the monocytes, B lymphocytes, antibodies, and also T lymphocytes, neutrophils. So honey is affecting most of them. And this is also another reason when you put honey on the open wounds, when it is sucking the edema or the lymph, it is also bringing other white blood cells into the area. So those white blood cells are our immune cells or defense cells. They come and kill the bacteria in the area as well. So that's another property of the honey. It is hygroscopic, which means that it will pull the water to itself when you put on your skin open wound. So when it is pulling the water from our body, which is called lymph, it will also pull macrophages, neutrophils, and other immune cells to the area, so which will kill the bacteria and which will kill the infection in that area as well. So honey has been shown to boost, and there's also another study show that the beekeepers who consume the fall honey, they become less prone to winter diseases. Again, it's not 100%, but there is a more percentage of like preventive medicine when you consume fall honey, and then to be prevented from the winter diseases like cold or flu or other winter diseases. Okay, next please. Yes. I'll come to wound healing now. Great, okay. So probably we have some nurses or doctors or health professionals here. So the wound healing has 4 major processes. So when you have a scrape or when you cut your hand accidentally, so what is the first thing happens? It bleeds, right? The first thing we need to stop the bleed. Sorry? You cut it like, F this, okay, whatever, yeah. So, so bleeding is the first thing that you need to stop. So that, because if the bleeding continues, the wound healing never starts. Okay, first thing our body does is clotting. So blood is clot, and then that is an open area. So this is a feast for the bacteria, because we have bacteria in our skin. Remember, we are 90% bacteria. They live on our skin, so they are friends of us. But they're also pathogens, or they are opportunistic bacteria. So when you have an open wound, they said, aha, we have fresh meat here, I mean fresh cells, and they just go in it, and they will cause infection. That's why if you have a cut, and next day when you look at your arm or whatever, if it becomes red, it is an infection, right? So which means that there is an inflammation going on there, it is warmer there, and then because our cells are fighting with the bacteria, infection. So the next thing you need to do is you need to suppress the inflammation and infection. So if the bacteria is there, that's why most of the wounds, like chronic wounds, they don't heal because of the continuous infection. I mean, I will show you some images which the person has wound for 2 years. So the wound did not heal for 2 years because of the continuous infection, and the antibiotics could not stop it. Again, most of the time, the infections will delay the wound healing. And then after that, if you once you clear the infection and suppress the inflammation, next step is you need to proliferate the cells, which need to close the gap, right? When you have an opening, so that's why we stitch it, right? We don't want a gap in between the cells. So that gap has to be filled by epithelial cells or fibroblast cells. So by this way, we have a confluent skin, like the skin is completely healed. And then the last phase is remodeling. So once you have the scab has to be removed, so no scar tissue is left. So honey cannot help the first one. Honey does not clot your blood, or doesn't help that much. But honey is helping for all other 3 steps. So next, please. Click on next. So honey is helping with the inflammatory phase. So it will, what it does is it will decrease the bioburden. It will decrease the cellular damage. It will decrease the biofilm formation. Remember, it doesn't have the biofilm. So bacteria cannot grow when the honey is there. And then it decrease the wound pH. And then it will also suck the lymph, or like absorb the lymph, and then more bacterial white blood cells are coming. So in the first phase. And the other one, in the proliferative phase, bacteria will increase the epithelialization, because honey is a sugar, right? So honey will increase epithelialization. So honey has lots of sugar in it, and those sugars will become a food for our own cells, not the bacteria, but for our own cells, and they will use this as an energy source, and those epithelial cells and the fibroblast cells will grow quickly. And in the final stage, honey will help with the wound remodeling, and most of the time, I mean, she's not here today probably, but there was a lady. She keeps coming. She kept coming for my talks almost every year from the TBA, and also she's on the board of the TBA as far as I remember. So she joined one of my talks about 3 years ago, I think, the one in San Antonio. So she had a cut on her arm when she was dealing with the bees. I think one of the nails. So she got a cut from here to here, like from elbow to the wrist almost. And then for half of it, because she wanted to try the honey. So for half of it, she put those butterfly connectors. And for other half, she only used honey. And then she showed me her arm 3 years later. She still had the scar tissue because of the butterflies, and no scar tissue left when the honey is applied. And she has the photos before and after. So honey doesn't allow the scar to be left there. Again, since you are beekeepers, always have some honey as a health thing on the side. I mean, as a medication on the side. And when you have a cut, when you have an incision, when you have an abrasion, or anything happens, just put one drop of honey into the Band-Aid and put it there. Don't put a neomycin or something else. I mean, I'm not against neomycin, but honey is antibacterial. Honey is helping your cells, good cells to grow, your cells to grow, and honey is preventing other ones. So always have one drop of honey. I mean, if you want, you can go to Walgreens or CVS and buy those pre-made honey Band-Aids. It's the same thing that you do at home, actually. So you can use honey directly on the Band. Again, I personally use it. It's a personal experience. I use it on my kids as well. But again, don't take it as a medical advice directly, but I use it. Next, please. So those are the graphic contents coming in. Remember, I told you at the beginning, if you don't like it, just look at the other side. Close your eyes. Okay, so this is how the honey is applied onto the patient. So again, there was a study in Malaysia, in University of Kuala Lumpur. 102 patients were enrolled in clinical trials using honey for wound healing. So what they did was, at first, the wound is cleaned with 10% honey solution. So honey in water, 10% or saline, both of them will work. So the area is cleaned, the dead cells are removed, the slough of cells are removed, and then this wound is very deep. As you can see in number 3, the fist can fit in it. This is such a big wound, and it's not healing for several months. And then after that, because the wound is so big, they don't put a Band-Aid there, they pour the honey into the wound. And then they make sure that it goes into the tunnels, they push it down with the gauze pad and everything. And then, see, they put the gauze in it first, and then another dressing on the top. So make sure the honey is there. So this is how honey is applied for wound healing, for deep wounds. For small wounds, as I told you, you can use a Band-Aid or a gauze pad. Next, please. So this is the same patient. This patient, when she was first involved in the study, she has lots of infection. As you can see, those yellow pus and dead cells, no more alive cells, like immune cells there. So this is like going bad. And as you can see, it is swelling because lots of edema is going on there. You can see from here, lots of stitches made by the doctor to keep the wound closer, but it didn't work. The bacteria keep growing there. And then after 1 week, as you can see, the whole infection is cleared. No more no more, bacterial growth there. And then no slough off, like dead proteins in there. And then there is kind of fresh tissues coming out from the bottom. And in here, as you can see, epithelialization starts. The wound is started to heal. And the week 4, the wound is much smaller, much thinner. And week 7, this patient was discharged just by using honey 7 weeks. Next, please. This is honey directly. And this is Tualang honey from Malaysia. So again, not every honey has medical properties. I will show them in the following slides. We need to use medical grade honey. And this is a diabetic wound. This is the patient which didn't heal for 2 years. This is a 26-year-old male. I mean, younger than most of us. So he got and he was diabetic, and he got a scratch under his foot. He didn't realize it. And then that got infected. He lost his foot because of an amputation from the ankle. And then infection continued, an amputation from the knee. Infection continued, an amputation from the thigh, from the hip. There's no more amputation. You cannot cut anymore after here. So the patient has a fully swollen wound. And after 1 week, I mean, when they open it up, again, it has lots of infection in it. After 1 week, it is cleared out. No more infection, no more slough. The fresh tissue is coming up, and this is week 3. And then week 4, because the wound is so big, they made a skin graft from the other leg and just closed the area. So, but the patient survived. Otherwise, the patient was going to die because of the sepsis. And again, these patients are recruited into the study after all the conventional treatments did not work. So they only involved, because the doctors were very resistant not to use honey because it has not been shown, like that honey has not been like clinical tried so much. And this was done in 2002, about 20 years ago. Next, please. And this is sword slice. This is a guy who fights on the streets. So he got somebody cut his arm with a sword probably, or a big, machete. And then he got infection. And as you can see, he will gonna lose his arm. That has to be amputated. Look at the infection there. I mean, it is swollen, lots of infection there. So 1 week after treatment, it is all cleared up. So no more bacteria. And 2 weeks afterwards, the wound is almost healed. We don't have the final picture because he ran back to the streets to fight. So, yeah. And next, please. This is a diabetic neuropathic ulcer in the patient. And this is only 3 weeks from here. Definitely amputated, should be amputated because the deep infection, you can see the bone, like that deep, and then that much infected. And then necrosis happens. And after 3 weeks, the wound is completely healed for a diabetic neuropathic ulcer patient. And there are hundreds of images like this that honey is being used for wound healing. And again, remember, throughout the history, honey was the #1 wound healing agent used by all civilizations. And all these studies has been collected under Cochrane collaboration. And this is one of the most reputable journals among the health professionals. And then this is honey as a topical treatment for wound healing. In 2016, they published this article, and in 2018, they updated it with the new clinical trials. And according to those studies, honey has been shown to be used for wound healing, but more improvements are needed. And hopefully we are going in that direction. Does anybody work in a wound clinic here or burn clinic? If you go there, I mean, I hope not, but if you go there, you will see Medi Honey is one of the common brands, or Manuka Honey or Manuka Med is one of the common brands found in the hospitals today that the doctors or health professionals are using honey for wound cleaning or wound healing. But again, you don't have to go there. Your own honey in your backyard can be one of the medical grade honeys. Next, please. And that's what we did in our lab. Okay. Do we need a break? Are we okay? I have about like five to 10 more slides. I don't remember the number, but anyway, this is what we did in our lab. I need some water. I'm getting dehydrated. Okay, so last year, I mean, in 2020, when I was a high school teacher, so I collected some honey samples from Texas Speaker Associations, but I didn't have the lab to analyze all of them. And I volunteered at UTSA for some studies. And then eventually in 2022, last year in January, I joined UTSA and I started to teach medicinal properties of honey as a class in fall, just like this last fall. And then there were 20 students in my class. And then we collected some more honeys from San Antonio and Austin area, like with Hayes County Beekeepers Association and also San Antonio Alamo Area Beekeepers Association. So a total of 110 samples we collected, and also some friends from different parts of the world, they sent out samples too. So we collected those 110 samples and we look for their bioactivity potential. So bioactivity potential is that if a honey can be used for bioactive like purposes, which is called medicinal purposes. If the higher bioactivity potential, the higher medical grade honeys. Next, please. So we can skip this. Next, please. So there are like 7 different types of honey colors that has been identified by USDA. So your honey can be from dark amber all the way to water white. And these are in this book, the Honey Connoisseur book. I'm sorry, what happened? I broke it. I don't know. Oh, sorry. Yeah, the Honey Connoisseur, this is the book that is telling us about how you can identify your honey's taste, but it also have all the colors, and I really enjoyed this book and also these ones. So what we did, these are the honey samples with different colors we collected from Texas at different locations. And as you can see, we have almost all the colors in our, what's it called? The diagram, or like in our wells. Okay, next, please. So we identified antimicrobial and antioxidant potential of honeys. So these two are sufficient to say if honey is a high bioactivity potential or medical grade. So we didn't try anti-cancer, we didn't try those other ones. Maybe in the future we will. But for now, we look for antimicrobial properties and antioxidant properties. So for antimicrobial, there are 6 different ways of measuring it. So we measured 4 of them. Actually, yeah, 5 of them. Sorry, 4 of them. We did the agar-well diffusion, hydrogen peroxide activity, metabolic assay, XTT, and cell-profile viability. This diffusion is mostly used for antibiotics like those discs. And then prevention of biofilm. We will do this hopefully this summer. So we analyze these honeys for how their potential and how their activities. Remember, potential is, like most of the time I give this example in the potential and kinetic energy. So when the child climbs up to the slide, so this is the potential energy. When the child slides down, this is kinetic energy. So potential, if you don't use it, it doesn't become energy. It doesn't become kinetic. So honey has the potential. First, we need to measure the potential, and we also measure the activity. So if that potential is converted into activity. So that's why we did different activities. Next, please. There you go. Yes, you got the answer. So this is the Staph aureus. This is the golden staph. So this is the pathogen that causes staph infection. And also it has a methicillin resistant Staph aureus as well. So this is the one that gains resistance. So we use this, we put the bacteria on the Petri dish, and this is a pretty big one, 150 millimeter. And then we make a lawn of the bacteria, and we make holes by a micropipette tip. And then we put honey directly, no solution, just honey itself into those holes. Each of them holds about 200 micrograms of honey. So what happens is that next day, and this is how the antibiotics are also studied. Like, for example, when the people find new antibiotics, they do the very similar procedure. So well diffusion. So we put something here, it diffuses. And what happens is that the more antibacterial activity, the higher the zone of inhibition. So when you see a clear area like this, they have more zone of inhibition. When you see a non-clear area or smaller area, these honeys don't have antibacterial potential. Okay, so the higher the zone, the higher the antimicrobial potential. This is how we measure the activity of the honeys. And we measure them with millimetric reasons. So if it is more than 16 millimeter, it is a strong antimicrobial. I don't say this, this is American Society of Microbiology is telling this in their book. So if it is more than 16 millimeter, it is strong antibacterial. Between 16 and 11, it is moderate, and less than 11 is weak. Next, please. Yeah. So when we did this on the, next, please. So when we did this on the Texan honeys, which is 2020, so we found about like, I think 6 or 7 of them has very strong antimicrobial potential. So they are larger, they have a zone more than 60 millimeter. Next, please. And then these are like, one of them was more than 20, which is Greg Ormond's from Temple area. And then 12 of them were more than 16. So we found that 22% of the Texan honeys, and we can see some of the common names here, like JJ Wickby here, Doris Siddleman, I mean, the president of TBA now. And yeah, we have some other like donors in here. So, and also we see here L-lecithin wound gel. This is one of the wound gels which has honey in it in the market. So this is in the wound clinics. And we have Volker honey. So the Volker honey donated 4 different samples to us. And we have some black seed honey, stingless bee honey, all of different ones. And we found only 22%. 1 out of 5 has strong antimicrobial potential. Next, please. And these are the San Antonio honeys, which are collected in 22. So that's just this fall. And we found that, as you see, there are so many of them are above 16. So the yellow line. Next, please. So we found that 2/3 of the San Antonio and Austin honeys, 2/3 of the San Antonio and Austin honeys have high antibacterial potential. So they are killing this pathogenic bacteria when they are put into the wells. And these are the highest ones. Like there are 4 of them, more than 20, like Rob Holby from the AABA's president, Alamore Beekeepers. We have Kristen Bosch from Poteet, Peter Cargo from Bernie, Randy and Tara Randall from the Hill Country. So these are the highest one, more than 20. But as you can see, like those pink colors and yellow ones, they're also 16. And Heather Wilk has one of the most ones, and probably you can see your names as well. Natalie is there, number 2. And next, please. So these are different colors of honey. And most of the time, we think that like the darker the color of honey, the higher the antibacterial potential. That is true, but darker color is good for antioxidant, not antimicrobial. So as we see this one, Kristen, well, this is the one from Poteet, and this is the lightest color, and it has the highest antimicrobial potential. And all these others are dark colors. Next, please. And we also measure for antioxidant potential, which we have 6 different ones, like TPC, FRAP, TFC. We measured like 4 of them. Again, we implemented 4 of them in our studies. Next, please. She's getting closer. 15. Okay, I'll be done. I didn't know we were done. Okay, so But look at this. When we look for the antimicrobial, Texan honeys were only 22%. But when we go antioxidant, we have 43% are above 100. So Texan honeys, like other than San Antonio and Austin, they have higher antioxidant potential. And some of them are like 474, 434. These are very high numbers in terms of phenolic contents. Next, please. Yeah, I mean, Texan is big, right? Everything's big in Texas. Even the honey. And look at these numbers. So these are the ones which has high antioxidant potential, the yellow ones. But these red ones, 10, 16, and 18, they are both high antimicrobial and high antioxidant. So these are the ones that has the highest medical grade potential. But again, if it is high antimicrobial, you can use it for wound healing. It doesn't have to be high antioxidant. High antimicrobial good enough for it. And next, please. And the San Antonio honeys, only 26% of them above 100. But again, we don't have 400s here. We have only 200s here. Next, please. And then among the San Antonio honeys, like these, 7 of them has high antimicrobial and high antioxidant potential. These are the highest medical grade potentials. So heatherwick, which has the oak honey, by the way. So oak honey is one of the highest. We have wildflower. We have, I don't know about this back. We have this is also oak, Peter Kauger. So, and Christy just, I think, so these are the ones that have like, you know, the purple ones are both high antimicrobial and high antioxidant honey samples. So which means that Texan honeys have medical grade honeys. So Texas have medical grade honeys. And this is the first time in the science that somebody is showing that Texan honeys has medical grade potential. And this year we'll be collecting more samples for my new class in fall. And in accordance with the HCBA, I mean, with the organization here, we'll be collecting more samples. So please get your samples ready, maybe in June or maybe in July, we will be able to collect your samples and then we can analyze them next year with our students. Next, please. Sorry. That's another thing, but we don't have that much of comparison. Maybe when we get this year, we'll be able to change them. So we'll be able to measure them because this is only one time we got the collection and only one is our first year. But by the way, I'd like to give you some good news. 22. Yeah, these are the ones from 22 fall. Hopefully, I mean, we have very good season coming up, lots of blooms. Yes. No, it was open to everyone. I didn't differentiate, but this year, but I have, I sent out a survey. I'm not the survey, but every person who's donating sample, they have to fill out a form. And in that form, it was asking about where are your honeybees located, like your hive location, zip code. And then if you know the nectar source, you need to write it. If you know your bee type, like Carnolian bee or Italian bee, whatever. And also we asked for about like if there's a fermentation on it and other questions. But we didn't ask about treatment-free. This year we will ask for it. So treatment-free or also hive type. Is it top bar or leg? We will also, we'd like also compare them. Yes.
If I would look further into another area that we mentioned, like honey for honey for plants.
Yes.
Can I go to the website?
Clinicaltrials.gov. Yes. If there's a clinical trial going on, they will show it. It is the government website. So any clinical trial will be there. But there are not so many clinical trials going on with honey. It is very limited. Most of the studies using honey for medicine is like from South Asian countries, from Europe and Australia, New Zealand, and some from Brazil, Argentina. Nothing from the US, unfortunately. This is one of the very few studies that we are trying. Hopefully we'll do more. Okay, so the result is that, yes, Texan honeys has antibacterial, antioxidant potential. San Antonio honeys has more antimicrobial, most probably because of the season that we collected them, because we collected them in fall. But for Texan honey, we collected them in July. So spring honey versus fall honey, that might differ. And then, and again, some of these will outcompete the Manuka honey. I have about, I just got 37 or 38 Manuka samples from another university. So Dr. Richard Wilson donated those to me, and I will be analyzing them this summer. I believe that most of the Texan honeys will be outcompeting the Manuka honeys in the market. So again, we need to do more about like to show that these are like Manuka is not making. Again, I'm not against Manuka because Manuka, if Manuka was not there, today we don't hear anything about medical grade honey. So Manuka is the one for more than 30 years. Manuka is being studied, and the Manuka is being like shown as antibacterial agent, and it is one of the highest one that is used in the market, and thanks to them. But again, it is not the only honey, because remember, like honey is out there for thousands of years, and Manuka is only from New Zealand. So, but in the Americas, in the Europe, different honeys are used. I think that's next, please. That should be last one. And some of our studies are shown covered in the media. So if you want to learn more about this, you can watch. And next, please. And thank you all. I mean, summary next. Okay. Yes, I'd like to thank you all for your patience and staying late today. Thank you so much. And feel free to email me if you have questions. And again, I will let you know when we are collecting samples, and probably you'll hear from the HCBA through the emails and Hayes County Pickles. And I can have questions if you want to stay longer, please linger around, or I can answer directly. Yes.
What's the difference between like a topical, like using it on a staph infection or an open wound versus ingesting?
Consuming, yeah. We have shown in the sorry. Oh, I think you need the microphone. You need the microphone.
We're gonna do a quick